In this presentation, we will present some of the key concepts of data warehousing. 1. OLTP versus analytical tools. 2. Different dimension model. 3. Star and snowflake schema. 4. Fact and dimension.
Let's now look at an overview of data warehousing and business intelligence. So once you learn about the SQLs, that can be used in the OLTP, that is the ERP system, which is called the online transaction processing we saw earlier. And then in OLAP also, that is called the analytical processing. So just again, a recap as we saw about the OLTP and why it is unsuitable for the analytical reporting. So the first point is that OLTP is more of a day-to-day service, and it is R2R service. When a sales happens, it needs to be recorded in the OLTP system. And sales happen in a location, in a country, in a geography, it all goes into the OLTP system. But you want to, generally in OLTP, it happens on yearly to yearly basis. And then those periods, those who come from ERP background, the periods in the sense 1 year period is what is being used, and then they post that they close that period, and because it is volumes of data is there, because of the structure of the database, it is not advisable to have a comparison what happened between now and few years back. So that is where they use analytical reporting. Because of the database structure, it is used more suitable for historical information, to analyze the historical information, you could put that way, to analyze the historical information, more suitable, that is the data warehousing system. And one of the thing is, it is normalized. The database design itself is normalized, meaning there could be many tables. When you have multiple tables, having a SQL join and retrieving data from it can cause performance issue. And generally, in a data warehousing, which is used for analytical reporting, it is denormalized, meaning there might not have many tables. That means, it is much more easier and simpler. The performance issue you might not face a performance issue there when it is denormalized. And generally, we'll see this. There's a star schema. They use the star schema or the snowflakes. Furthermore, the OLTP is disparate and multiple sources could be there. What do we mean by multiple sources? Meaning, any large corporate or even for mid-sized multinational company, generally if you see that, different MNC in a location, say for example, in US they might use a different ERP system, whereas in India they might use a different ERP system. But though these days they are trying to standardize, but still I would have seen the organizations like using different ERP system in a location, in a country. US might use APAC, Singapore might use a different system, and China might use a different system, whereas Japanese would use a different ERP system because of the regional preference, and sometimes acquisitions. They would have acquired a company, and that acquired company would have used a different ERP system, or a joint venture, meaning they would have a kind of a joint venture between two entities. Say for example, in India, Toyota car has a joint venture with a company called Kirloskar. So Kirloskar would have used a different ERP system. So multiple different sources. When they have a multiple different sources, the products there could be defined in a different way. Toyota cars would be defined in a different way in India, whereas it could be defined in a different way in a Japan-based system. So a top organization, a top CEO level, when they want to have find out a car sales, the car A, would be of same configuration as car B in Japan as well. So they just want to combine both the data, car A and car B, and so that it is, because the features, all the details, engine structure, everything is same as A and B. It is only that it is defined as A in India, whereas it is defined as B in Japan, but it's the same product. In that way, it needs to be integrated and reported. And that is where the data warehousing plus the business intelligence plays a critical role. For example, if there are 1,000 cars of A is sold and 1,000 cars of or 10,000 cars of B is sold in Japan, combined will be 1,000. Actual reporting should be 1,000 or 10,000, 10,000 plus 1,000, because that many cars needs to be integrated. So in Japan, if you say 10,000 and in Japan, and this is B, and then it is 1,000 as A. This is A. This is what is sold in India. Then the total should be reported as this many cars has been sold, total cars. And because feature wise it is same, engine wise it is same, so that is what is needs to be reported. If it is referred by different name, then the top management might not be aware what is A in India and what is B in Japan. So basically it should be reported as 11,000 of common car, because that is where whatever the top organization A, B, and they say as only top, the top organization CEO refers it as only as B, then the top organization should see as 11,000 of B. Or the top organization has a unique name, say they refer it as C, then the topmost person should see it as C only, the 11,000 cars. Should not see as B, should not see as C. That is where the data warehousing process, we will see that is where the process of extract, after that you will have to transform and load it. During the transformation stage, you transform A and B into C and load into the database, data warehouse database, and then this is sent across as for reporting. So that ETL, process of ETL plays a critical role, because you'll be extracting, this is an extract process, you will be extracting this data 10,000 and you'll be extracting B also get extracted, but then this gets transformed into C and then gets loaded, and naturally the value are summed as well. So that is where the ETL process takes care. So again, whatever I discussed, I had put in the PowerPoint as well, like a different operational system or the ERP, it gets extracted, loaded. Sometimes they load it and then transform, or they could transform and load it as well. So there are different, different tools which perform this role, but it is generally, it is ELT. They call it ELT process: extract, load, and transform, or ETL: extract, transform, and load. So there are tools for that, and that gets it gets loaded into the database based on whether it is star schema or it is snowflake schema. We'll see that gets loaded, and then the OLAP tools, analytical processing tools, generates the report, and which is viewed by the decision makers. So it goes into the staging area. Again, the effective data extract, transform, and load process represent the number one success factor of your data warehouse. Can absorb 70% of time spent on the special data warehouse projects. So the transformation can happen during the staging, after staging, post staging, during the loading into target, or once it gets loaded into the target, there could be SQL updates which gets updated for all the products. A, B will be transformed into C, as we saw in the example. So the ETL processing itself, even a decade or 15 years before, I had worked in a major corporate where extensively, because it was on the Unix based system, they had used shell scripting, SQL, SQL alone. So major corporate where it has operations across the globe, they use shell scripting, SQL, SQL. But additionally, these days, in the last decade or so, they use the tools to perform this much more simpler. much more effective also. Like Oracle has data interchange, ODI, there is Informatica, and the most recently Apache NiFi, which is open source. And these days, there are also the ETL tools, which is offered as a cloud platform. And as far as the analytics goes, I mean, for reporting, there is OBIE, there is Cognos, business objects, MicroStrategy, and many more also. This is just a sample. OBIE, for example, came out from the acquisition from Sibel, and Cognos, again, it was acquired by IBM. Business Object was separate. It was acquired by SAP. So there are acquisition. Initially, all of them like Oracle had e-business solution. They're all focused on OLTP solutions. The overlap was from a different vendor. Because a small piece, most of the major OLTP system manufacturers like Oracle, SAP and all acquired the OLAP tools like Business Object, Cognos and BI. More from a business perspective. But yes, these are the analytical tools. So it's a combination of ETL tool and the analytical tool which determines the success of data warehouse. So thank you. Stay tuned. Let us now look at the dimensional model, because that is plays a critical role in defining the data warehousing systems. So there are different models. I mean, the first one is the business model, and because the business model happens when you want to have the transactions registered, how the transaction flow happens, because once the order entry is made, then it gets into the accounts receivables, and then you receive the payments for the order. That is one cycle. And then you also procure goods. When you procure goods, then you have to pay for the goods. All this, you define the business model, and then based on the business model, you get into the, all this is for the ERP system or OLTP, the transaction processing. Then you define the logical model where you have the ER diagram, and once this happens, then the next stage is where the data warehousing, all this is under the data warehousing. So a lot of, I mean, without an ERP system, you can't get into, ideally you can't get into the data warehousing part. So each model has to be effectively made, and then you'll have a meaningful information for the business analysis to be made on the data presented, and decisions can be taken based on the available data. So from a definition perspective, we saw the business model. The strategic analysis strategic analysis is performed to identify the business process for implementation in OLTP, data warehouse, and this should be OLAP. So, I mean, large corporates or large MNCs has business leaders who sit together and decide the business model. The business model is subject to change, because over here, I mean, few years down the line, there is much more improved system. Then they again regroup, or it's always think it this way. It is always an ongoing process. That is where the business leader look out for an effective way to design the system. Not only design the system, use the system so that meaningful information are derived out of the system, which can be used for strengthening their product for the future. The future is important because the company has the vision, and based on that vision, based on the market demand, they should give the product. Just as an example, like the mobile phones, 2 decades back, you would not have thought about the smartphones. So definitely they would have done analysis on based on the customer preferences, what they are looking at, and then they came out with smartphone products. And similarly, all this analysis on which segment a product has good sales, that segment needs to be targeted and decisions needs to be made. So first is defining the business model, and then comes the defining the relational and logical model. So business process and identify the logical relationship, and this is where the ER diagrams plays a entity relationship diagram plays a critical role, and ER diagram gets transformed into the the data model, that is the relational model, that is where the RDBMS happens, and that is where DBM, yes, and that is where the OLTP online transaction processing happens as well, or the OLTP system, you can say. And the next two steps is where the dimensional model, because in data warehousing needs to be considered as a multi-dimensional model, because you have the transaction which is called as a fact, and that fact in a different dimensions like regions, countries, and by the product category, they need to analyze and come out with meaningful information which is helpful for the business for the future growth. So dimensional modeling and the physical modeling is where the data warehousing and business intelligence plays a critical role. So, I mean, from a definition perspective, let me read through it. The business model is transformed into a multi-dimensional model, warehouse schema tables, that is star schema, and snowflake schema. Let's look at that. And table elements are defined. And physical design, look at the most effective way of storing and retrieve the object data. So basically the OLAP layer, you define all this, the physical model, you define the physical model, logical model, and then yeah, you retrieve the data. So the last two is where the data warehousing plays a critical role. Again, we had done sequels, and if you look at it, this is how the relational model is going to look like. We had been working on particularly the employees. The employee ID is the primary key and department ID being the primary key over here. And there is a relationship between the employee table and the department table through the, of course, through the department ID. So there could be multiple entry of departments in the employee table, whereas here needs department ID has to be unique. So this is, you have a kind of a multiple relationship between tables in a relational database, whereas it will be based on the, we'll see that star schema and the snowflake schema. Before that, here in data warehousing, it's all about the fact tables and the dimension tables. You'll also see what's a fact table and dimension table. So identify the, so actually all the transactions level, I mean sales transaction actually happens, whatever happens, that is the fact table, the actual transaction detail. Dimension is how do you want to view the data, different dimension, time dimension like quarterly or monthly or yearly comparison. Those are differentiation. Then on the product basis, maybe in the smartphone, different varieties of smartphone, which variety of smartphone, subcategory of a smartphone or category of the smartphones, those are dimensions. So the facts and dimensions play a critical role in data warehousing as well. And as far as data warehousing is concerned, two schema, one is a star schema, and the star schema is the most common one. If it is simple, in case of some kind of a complexity, they get into snowflake schema. And star schema, you have the facts table at the center, and all the dimensions are at the it looks like a similar to a star, so that is where it is called a star schema. Whereas in the snowflake schema, it will be slightly different. So you have the center wherein you have, because if you look at it, you have the sales amount, the sales unit, which is all the transactions. So that's about the star schema. We'll continue with the snowflake schema in the next presentation. Thank you. Stay tuned. So just to recap, we saw about the star schema and the snowflake schema. We saw about the star schema where the fact tables, which is actually related to the transactions, will be at the center, and there are going to be, so it will has the join conditions. So all the dimensions will have a primary key, which is referenced by the fact tables. So that whenever there is reporting needs to be done, it could be based on this, for example, the sales across stores. Across stores, that is one dimension. Across items, that could be a dimension. Across the time, that could be a dimension. Across product, that is a dimension. And the center is what is the fact. So having a star schema and retrieval, data retrieval is much more faster rather than if it is a kind of a normalized database in OLTP system, it's going to be a challenge retrieving all the data. One is that it is not at a center place. Here, we using ELT, I mean extract, load, transformation. You extract the data, load it into a single source of truth, single database, and across the globe, the data is extracted and loaded, and then you use them for reporting. That way, it is much more effective. I mean, using the data warehousing system with the star schema basis. But in some cases, based on the requirement, the complexity can increase. In that case, you might need to dissect the fact table into multiple fact tables and even the dimension tables into multiple dimension tables. So this is more or less, it will be something like a relational database, but yeah, improved version. From a data warehouse perspective, the Snowflake schema is an improved version, but more or less it will be something like a the OLTP system where you have facts tables and the dimension table. Snowflakes is random. It's all randomized, little bit randomized. That is how you need to visualize. So that's about this star schema and the Snowflake schema because that plays a critical role in the data warehousing system. So I have hope you have some clarity as what is a star schema and Snowflake schema. So stay tuned. Thank you. So we had been discussing about the fact tables and the dimension tables. Let's look at some of the characteristics. There could be plus or minus, but generally, as we said, numerical metrics in the business holds a large volume of data because that is the transactions. As I said, day in and day out, if quantity sold or amount sold, total amount is going to be captured. The fact tables is going to quickly grow. So grows quickly, contains the base derived of summarized data. If you're capturing something like total amount sold, then it is summarized data. And joined through the dimension table through the foreign key, primary and foreign key relationship. Primary key will be in the dimensions. So you got to, when you want to go into that particular dimensions and see how the sale has happened, then you use the join condition of that dimension and get the data. So this is the characteristics of the fact table, and then the dimension table is where probably like it has the one dimension. As I said, it could be stores dimension or a country dimension. So those are the dimensions. And translating the business dimension into dimension tables itself is always kind of a tricky issue. That is where the business leaders and the technical folks, because technical folks is who is going to design whether it is star schema or Snowflake schema, because the business leader will not understand. Business leader will provide the requirement. How does he wants the report? Product by category, it could be category by subcategory or by status, by product list. So many things are there, so many dimensions. But generally people tend to confuse and okay, dimensions, it is based on country, customer, that is what they look. But that is where the business leaders who knows about all the business process has to discuss with the technical folks in deciding the data warehousing, because data warehousing, unlike the ERP system, the OLTP system, which is kind of ERP is always standardized. If you are using Oracle e-business suite or SAP, it's all standardized. The modules works in a certain way. Whereas in data warehousing, invariably it's all customized. When you have a data warehousing built in a customized way, there needs to be a good understanding of the business requirement, and because the technical folks is going to design the data model, the star schema, Snowflake schema, or whatever it is. So they need to sit and discuss with the business requirement with the business leader or the business process leader and come out with a data warehousing solution. Many times this is overlooked, and it, I mean, compared to success rate of OLTP system, ERP system, the success rate of the data warehousing and business intelligence system is much less. And one of the primary attributing reason is that understanding of the requirement from the business leaders. It needs to be effectively understood. Even the technical guys needs to have a functional knowledge, and then they can decide about designing it. And again, time is as well as critical, not just the requirement, many times it's a statutory requirement as well. How was the statutory in the sense when you report to the stakeholders, what was the sales last year, whether it has grown or fallen. So the time factor is as well important, and it needs to be fiscal year, quarter, month or week. Time dimension plays a critical role. And this is where we have seen all the functions like, data warehousing system like role app, cubes, all this hierarchy, by the way, like product hierarchy. We had seen the employee manager hierarchy just as a example, but in a product, different product, how they roll up to a product. So all this hierarchy system, you can define the reporting. So I hope now you have some understanding how the data warehousing and business intelligence works and how what are the tools involved. But the point you need to understand is SQL and for to an extent PL/SQL is extensively used, because whether it is OLTP, that is online transaction processing, that is ERP, or OLAP, SQLs are extensively used. Thank you.